Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of September. Once again, my name's Warwick Rudd, and I'm hosting you again this month. For this month, we've got Angela Henry talking to us about data types that do matter. Now, I will hand over to Angela very shortly, but before I do have a couple of housekeeping slides to run you all through. So first off, a big thank you to our sponsor, SentryOne. Without our sponsors, it does make it difficult for us to run these sessions. So if you haven't already gone along to the SentryOne website, have a look at what's available for you. They've got fantastic articles, videos, downloads, and lots of demos available to assist you in your data platform learning path. For those of you who don't know, Past Summit is coming up very, very quickly, where if you're still wanting to register, you still can. If you use the codes that we've got on the screen right now this session is being recorded, so you can come back and see this, but if you use these codes, you can actually save yourself another $150 off of the purchase price of your ticket. If you are coming along, I will be there just as an attendee, but Angela will also be there, so make sure you swing by and say hi to us while you're at Summit. Make sure that you stay connected using the SQL Pass hashtag or the SQL Pass Twitter handle, and you're able to keep up to date with everything that is being mentioned on Twitter around all things SQL Server. So with that, I'll now hand over to Angela to take us through this month's session.
Well, hello, everybody. I was ready, and now I'm not so sure, and I don't remember, so I'm checking one more thing. Okay, I do have everything started, so let's get down to business here. And, all right, can everybody see the slide deck?
Yes, we can.
All right, great. So I'm Angela Henry, and Data Types Do Matter is the name of the session. Quick bit about me. I'm a DBA. I've been doing this for a super long time. I'm not going to tell you how long, but it's been a long time. I've got my MSCE in Business Intelligence. I'm a data platform MVP. I am also the local group leader for the past chapter here in Greensboro, North Carolina. I tweet, I blog, and then, you know, if I'm not playing with data on my computer, you can probably find me at the pool because I am a very big advocate for swimming. And my 5-second soapbox here, if you don't know how to swim, please learn. It is the only sport that can actually save your life. I'm off my soapbox. All right, quick overview. We're just going to jump right in. So we're going to talk a little bit about data quality. We're going to talk about storage, and we're going to talk about performance and how your data types can actually affect all of those things. So last count, there were actually 35 data types in SQL Server. That's a lot. We are not going to talk about all of those today. What we are going to talk about are things that I see most commonly abused, misused, used incorrectly, whatever turn of phrase you'd like to use there. And that's when we're talking about dates, date times, you know, temporal data, numbers, and how people like to store them in character fields. I see this quite frequently. I do a lot of BI work and having to move data around, and this is something that I just see constantly. So, you know, it's everybody's favorite data type, the character data type. And I know I'm not the only one who said, you know what, I just need something quick and dirty. I just want this data to load. I'm just going to shove it in as a character so I don't get any errors. I'm going to go back and I'm going to deal with it later. I've done it. And you know, if it's a one-off, if it's a quick and dirty, it's not going to be permanent in your database, by all means, welcome to it. Just know that when you do that, there are some data quality aspects that you need to be aware of if you're going to do that. So with that, we're going to jump right into the demo. And before I do that, are there any questions out there, Warwick? I'm gonna say no because I haven't heard from anybody and I don't see any. All right, let's get right into the demo. So if we come over here, so what I did is I started out with the invoices table from the Wide World Importers database. It's one of the sample databases that you can download. I believe it's on GitHub now. And I just made a copy of that and I dumped it into my own database, my data types do matter database. As you can see, you know, an invoice is something that's pretty common so that everybody kind of knows what we're talking about. And then what I did is if you look, you'll see that there is an invoice date here. And what I did is I added an additional column to my copy of the table and I created it as a varchar 20 and then I just populated it with the value that was actually stored in the invoice date. So when I take a look at this, you get an idea. All I did was add that additional column and populate it based on what was in the invoice date column. And I've stored it as a varchar 20. So then what I did is I went through and I picked a specific date, August 7th of 2015, and I modified a number of those values in the varchar 20 column so we can see the differences. So when I when I look to see what the count of distinct invoice dates are when I'm looking at the actual date data type column, we would expect that to be 1 because there really is only one August 7th of 2015. Now I know because I am in the US and Myanmar is the only other country in the world that uses the month-day format. You're all thinking, geez, Angela, that's July 8th, not August 7th. So I am in the United States. You'll have to forgive me. I am using the month, day, year format here. But that is something to be aware of because if you work with people from a different country, they may be using a different format. So now when I do a distinct count on the column that is storing the invoice date as a varchar 20, we would expect to get 1, right? Because there's only one August 7th. But look at that. I actually have 10 records. So we already have a discrepancy in our data. Our data quality has already been affected. So if we drill down and we say, okay, well, instead of distinct count, let's just look how many records are there where the date column is August 7th. We run that one, there are 62 records. When I come back and we run it for the varchar column, we've got 3. So we're already missing 59 records. Again, our data quality has been affected. So let's do some comparisons. What about max and min? So when we look at the invoice date column, it's January 1 of 2013 up to April 30th of 2016. But when we look at the varchar 20 column, completely different dates. Now, if I were in the US, which I am, that would read July 8th of 2015, but it goes to August 7th and there's not even a year there. So not even close to the same values that we got when we looked at the date data type. So what happens when we try to convert that? Because that's our first thing. We're saying, oh, well, you know what, we got stuff in there. Let's convert that. So if we use the convert function, oh, we actually get an error. And what happens, we'll try the cast function because some people like that better than the convert. Same thing, we've gotten an error. Well, Microsoft was super nice to us and they said, okay, well, we're gonna give you these functions, this try convert and the try cast. So what happens when we try those? Well, we don't get any errors, but now look at that, we've got nulls in here and you can see the different dates that are listed over there. is in the varchar column versus the actual date data type column. So when we go and look at the try cast, same thing. We get an answer, but it's not the right answer because we've got nulls in there. It doesn't know what that is. It doesn't know how to convert that, so it returns a null. So again, our data quality has been affected. So let's look to see what we actually have in there. I'm going to zoom in a little bit so you guys can see that. So we have lots of different values in here. You know, if I'm in the States, that's July 8th. If, you know, versus August 7th. But if I were, you know, down under where you guys are, that's a valid August 7th date. So again, you have to make sure that you're using the right data type for your data, or you're gonna have data quality issues. Now that was with dates. What about numbers? I'm only going to talk about whole numbers. Just know that numbers are affected basically the same way when you're using decimals or floats or non-whole numbers. So now I just have this little table. It's got 17 values in it. It's the same value in each. The first one is stored as a varchar. The second column is stored as an integer. So they're the same values, they're just different data types. So let's come back and see how this affects it. So when we look at everything, when we compare the integer column for everything that's greater than 10, we should get 8 records. All right, so let's see if that's true. And yep, sure enough, there's all 8 of all of those are greater than 10. But now, if we go back and say, so, and people have kind of given me some grief about this example, and it's a very oversimplified example. But if it's a database that you are unfamiliar with and you see that it's being stored as a varchar, you're going to compare it to a varchar, not knowing. So let's compare the varchar column to a varchar 10 and see what happens. Well, because it's not being stored as an integer, those are all greater than the string of 10 because they all start, you know, with something that's higher than a 1. And then here, well, 111, that's definitely greater than 10. All right. So what happens if we see that, oh, yep, we really are just storing numbers in that varchar column? Let's go ahead and compare it to a number. So let's compare that varchar column to a number and see if we get the right answer. We actually do. Now, the key with that is, yes, we do get the right answer, but it's going to use an implicit data type conversion. It's going to come at a cost, and we're going to talk about that in the performance section of the presentation today. So let's see how it affects our ordering. So again, I've got that same table with those same 17 records. Let's come over here and let's order them by the integer column in ascending order. And yep, sure enough, that's in ascending order. It did it just like it was supposed to. But if we come over here and we order it by the varchar column, yeah, that's not in the right order. It's using a string. So I'm using the standard accent sensitive, case insensitive collation. So it's everything with a 1 is going to come first, then everything 2, then all the 3s, the 4s, you get it. So just know that if you need to sort your data and you are storing numbers as strings, you're not going to get the data returned in the order that you're assuming that it's going to come back in. So again, your data quality has been affected. So before I go back to the slide deck, do we have any questions out there?
No, we don't, just as yet.
Okay, all right, we will just keep going on with the slide deck then. All right, so data quality, how does it affect if we're using the wrong data type? It affects our comparison operators. So we're actually going to get the wrong answer if we're not using the right data type. And it affects our sorting capabilities. So if you're expecting results to be returned in a specific order, you could very well be surprised by that. So the old adage, garbage in, garbage out. That's what happens if you don't use the correct data type when you're talking about temporal data and numbers. And it goes for other things, but that what we're talking about specifically in this session are just numbers and temporal data. All right, so we've seen how it affects your data quality. So let's see how it affects your storage. So it's just a number, right? Doesn't matter. It's string data. Who really cares? And a date's a date. I've heard all of those multiple times throughout my career. And I just want to bang my head up against the wall and say, no, that's not true. So we're going to see why that's not true. So let's take a look at numbers first. So again, we're only going to look at whole numbers. So you've got your big int, your int, small int, and your tiny int. The ranges that each one of those fall into, and then the number of storage in bytes that they take. So, tiny ints 0 to 255, not a whole lot of numbers there. Now, I am not advocating to always use the smallest data type possible when it comes to numbers. What I'm really advocating is know your data domain, know your data, know what could possibly be stored in there. And if you're only ever going to store 10 things, do you really need to store that as a big int? When you're working with data warehouses and that becomes a foreign key in your fact table and you're storing a big int instead of a tiny int, it's going to add up super fast, super fast. And with that, let's take a quick look at our demo. So let's come back over to our demo. Let me hide this over here so I can actually get to that. All right, so I'm just going to do a little bit of cleanup for my session. I was rehearsing earlier, so make sure we're starting with a nice clean slate. So again, I started with a table from the Wide World Importers. It's the delivery methods table. We've got 10 records in here. That's it. Okay. They're actually storing this as an integer in the delivery methods table. So again, I just created a copy of that table, brought it over into my database, and then what I did is I created additional copies so that one of them stores it as a tiny int, one as a small int, one as an int, and one as a big int. So if I just look at the contents of that, you can see it's not anything fancy. So let's see how much space we're actually using in those tables. So I wrote this little stored procedure that kind of formats it so I don't have to have several lines in there to show you this nice pretty output. So I'm only storing 67,000 records, not a whole lot. And when I store it as a tiny int, it takes, almost a meg. I don't have any indexes on it. But when I store it as a big int, the exact same data, it takes an extra 500K or so. 500K. What's 500K in the grand scheme of things? It's nothing. It's nothing. Storage is cheap, right? All right. Well, let's go back. And, we want everything to go faster. So let's create indexes on each of those columns. And I'm just creating non-clustered indexes. And let's come back and see how that affected the size of our tables. I'll zoom in a bit here. Now look at that. now, instead of almost, a meg, it's a little bit more than doubled in size. So I have a percent change over here. One attendee in a session that I did down in Baton Rouge actually suggested this change, and that actually, you can see that difference. It makes a huge difference. So, it's more than doubled in size in every single case. But now, instead of a 500K difference, we're talking about a 1 meg difference. But again, it's 1 megabyte. Who cares about 1 megabyte? Well, that only had 67,000 records in it. What happens if we have a table with 10 million records in it? Well, obviously the data space is going to take more, because instead of storing 67,000 records, we're storing 10 million records. So now we're going from 139 meg to 209 meg. So that's a 70 meg difference now. 70 meg, well, we have terabytes of storage. Who's really going to care about 70 meg? Well, again, everybody wants their stuff to go faster. So let's create indexes on those tables. Again, we're just creating non-clustered indexes, and we're doing it on each one of those. And this takes about 20 or 30 seconds to do. So, all right. I just got a new machine, so it runs a little bit faster. So let's see how that has affected our storage. So when I run it now, look at that. Again, we've more than doubled in size, and instead of a 70 meg difference, we're now talking about 140 meg difference. That's just one column in one table. But it's still only 140 meg, so, we got terabytes of data. It's all good, right? I don't know about you guys, but my SAN administrator, he calls me the greedy DBA, because I'm always asking for more space, more memory, more everything. So it does add up, and it adds up very quickly, and he would be very angry if he found out that I was wasting that much space. So with that, let's head back to our slide deck. And before we get going on our slide deck, are there any questions out there?
Okay, Angela, we've got a couple of questions for you.
Okay.
Now, when working with date time for the purpose of tracking events, what are the considerations in picking date time 2, date, and time in terms of ease of use and compatibility with presentation tools, etc., like Excel, Power BI, and reporting services?
So first thing, and we're actually going to talk about dates in just a little bit, but to kind of prime you for that, first of all, you need to know what precision, how accurate does your data need to be? Do you actually need a time element to the date that you're storing? Sometimes you don't. Sometimes all you need is just a date, and that's okay. But other times you need it to be down to the millisecond, or you need to be down to the nanosecond, because you've got, what if you're running, a gaming site, and you have to figure out, what happened first, and you have to, so it really comes down to, you have to know your data domain. But there are considerations. When you look at date time 2, that is not actually supported in all application development languages. So you're going to have to know. One of my attendees actually gave me a name of a language, which I can't remember off the top of my head, where date time 2 is not supported, even though date time 2 has been around, and not just in SQL Server, but in other RDBMSs. Is not supported in that specific language. So you're also going to have to know that as well. And then as far as presentation goes, again, what does your audience want to see? Do they want to see it down to the millisecond in a report, or do they just want to see the date? Do you need to be able to break it down by hour? Do you need to be able to break it down by minute? If you're doing Power BI and you want to be able to create those buckets to put your data in. So you can see if you have, something, it always happens at 5 after the hour, every single hour, then that's the only time you've got a spike. That might be something that you need to know. So again, you just need to know your data domain and figure out if that is the information that your users need and require.
Okay. Will there be an issue with the bit data type?
So the bit data type is treated a little bit differently. Some languages treat the bit as a Boolean. Some languages treat it as an integer. So it's a 0 or a 1. So again, you're going to have to know the language that you're using and how it's going to be translated in that language. So you're going to have to do your research and find that out. But just know that those are some things that could happen.
Okay. So I've got a table with an amount as an integer, and I send a variable at amount as a small int, assuming amount in the table has an index. Will I use that index on the amount table, passing the small int variable data to it?
The short answer is no. And the long answer is we are actually going to talk about that when we get to the performance aspect. So if you can just hang on for no at the minute and wait for the explanation when we get to the performance.
Okay.
That would be great.
And just not a question, but just some information. We've got, so datetime 2 is not working in Access for me. That's not me, that's the attendee. Okay, so we're good to keep going.
Okay, all right. So that is good to know. I didn't know that Access didn't support datetime 2, so I learned something new today. Thank you. All right, so they're not just numbers. They do make a difference, and they do make a difference in storage. So again, understand your data domain and what needs to be stored and plan accordingly. Again, I'm not advocating use the smallest data type available. I'm advocating knowing your data domain and know what you need to use. All right, so now let's talk about string data. So I'm not sure if everybody's familiar with the difference between fixed length and variable length. So just a quick primer on that. Fixed length means that if you declare a char 10, it will always be 10 characters. So even if you are only storing 2 characters, AB, it's going to pad that out with spaces. So even though you only have 2 characters in there, it's actually going to store all 10 characters. Whereas variable character, if you have a varchar 10 and you're only storing 2 characters, those AB, it's going to store 2 plus, so that, which is the length of the data, plus 2 bytes. So it's actually going to store 4. So you have to kind of, when you're working with smaller things, you have to take things like that into consideration. And then your nchar and your nvarchar, those are the Unicode versions of the char and the varchar. So, fixed length 1 to 8,000 for char. Your variable length, you can actually go up to 2 gig if you're going to use the max. I have some people who say, well, if we can use max, why not just use max all the time? Well, you could, but that's going to affect your performance, which basically boils down to it's not going to use your indexes. I mean, there's a whole host of other problems that are going to come from using varchar max for everything, but basically it's not going to use your indexes is what it boils down to. All right, so let's jump right into this demo. All right, so we are working on our storage. So again, I'm going to do a little bit of cleanup here from when I was testing earlier. All right, Again, I took data from the Wide World Importers database. I grabbed the cities table, and all I'm doing is I made a copy, and all I'm doing is storing the city ID and the city name. And I created copies that have the city name stored as a char 255, a varchar 255, and an nvarchar 255. And it's all the exact same data in each table. It's just the data type that's different. So if we take a look at our, whoops, I hit the wrong button. Sorry about that. So we're only storing 37,000 records. Again, you know, for a varchar 255, it's storing about a meg. But look at the difference when you're storing it as a char. That's 10 meg. That's a big difference for that small amount of data. So let's see what happens, you know, because of course we want everything to go faster. So when we create an index on those, again, we're just creating a non-clustered index. We'll come back and we'll see how that has affected our storage. So again, it's more than doubled our space that we're using to store that data. Now, instead of, you know, storing an extra 9 meg, now it's an extra 18 meg. Again, you know, 18 meg in the grand scheme of things, it's probably not going to hurt anything. But again, what happens when you have a big table of 10 million records? Look at the difference here. We go from 260 meg to 2.7 gig. That's 2.5 gig difference now. And that's just one column in one table without any indexes. That's an extra 2.5 gig to store the exact same data. So let's go back and let's create those non-clustered indexes again and see what happens. So do we have any questions hanging out there while this one runs, Warwick?
Okay, so we do. I want a little bit more information first on one, but the question was, what's the impact on memory grants and performance within memory and CPU? So if we can get a little bit more of clarification around that, then we can get a better answer. So while we're waiting on that one, is there a difference between declaring a column as varchar 50 and varchar 2000?
So is there a difference between storing do you say a variable or a column?
No, so a column.
Okay, so storing a column as a varchar 50 versus a varchar 2000?
Yes.
Okay, so there is a difference, but the difference is going to depend on what you're actually putting in there. So if you know that it's going to be more than 50, then, you know, and if you know it's going to never be more than 2000, then you're good to go with the 2000. Just know that, you know, it's going to be whatever is actually stored in there, the length plus the 2 bytes, because it's a varchar. But if you're going to have to compare it to another column of a different size, even though it's a varchar, it's still going to encounter that implicit data type conversion that we're going to talk about in a little bit. So I'm not sure if that's really answered the question, but yes, there is a difference, and it's in storage.
Okay, no problems.
All right, so, all right, our index is done building. Now we look at it, and look at this. We went from 250 meg to 500 meg, and we went from 2.5 gig to 5 gig. So we went from 2.5 gig before any indexes to an extra 5 gig to store the exact same data. Now, again, your SAN administrator might not think too much about megabytes being wasted, but now we're talking about 5 gig being wasted. And again, that's just one column in one table. All right, so that is a big, big difference. All right, so did we get any clarification on the other question before I go on?
Yes. So what's the impact on the memory grants and performance within memory and CPU of using tiny int versus int for the query performance?
I honestly don't know. I would probably have to write it and look at it and see, because off the top of my head, I honestly don't know. Do you have an answer for that one, Warwick?
Like you, I'm in the same boat with. My only take would be, from a comparison point of view, if you're doing implicit conversions, then it may cause you problems.
That's going to cause you extra CPU cycles.
So,
okay. All right. So it's not just string data. You need to choose your data type wisely, especially when it comes to char and varchar. So good examples of things that are chars. So in the United States, we have what's called a social security number. It's always 9 digits long, always. It's never anything else. It's always 9. So you know you could use a char 9 for that and you would be okay, because it's never going to be 8, it's never going to be 10, it's always going to be 9. But what about a phone number? Would a phone number be a good thing to store as, you know, fixed length or variable length? Well, if you're storing international data, probably not a good idea to store it as a char, because different countries have different length phone numbers. So a varchar would be a more appropriate selection for a data type when you're looking to store a phone number. So those are just some really super simple examples of, you know, when you would use a char versus a varchar. You know your data. That is, if you take nothing else away from this session, it's know your data and know the data domains that you're going to be using. All right. Now we're going to talk about dates. Were there any other questions before I keep going?
yes. So,
okay.
If we were, excuse me, some application vendors inform that nvarchar will have better performance than varchar. Is this true?
nvarchar has better performance than varchar, and it's coming from a vendor. So without more context, I can't really say whether it's true or not. I can give you a scenario where it would be true, and that is if the vendor has stored their data in nvarchar data types and you are writing stored procedures or something to go against that data, and you're storing it into, you're going to dump it into a char, then it's going to, you have to do comparisons between a varchar and char. So it, you know, it's going to have that implicit data type conversion because the engine's not smart enough to be able to compare 2 different data types. It has to convert one to the other. So does that kind of answer?
We'll wait and hear back. So, but following on from that, from a different question, but it is considered. What are some use cases for varchar versus nvarchar, and when is it appropriate to use one or the other?
So the biggest use case for varchar versus nvarchar, if you are going to be storing anything that uses the Unicode, you're going to need to use the nvarchar, because you need that extra byte in there for the double width of the character. So that's what I, you know, if I ever have to do any work where I'm storing data that comes from outside the United States, I will store it in an nvarchar because their collations are different and we're going to need to be able to store that information.
Okay.
Got it?
Can we create an index on a nvarchar max column?
Can you create an index on an nvarchar max? I actually don't honestly know the answer to that because I've never wanted to. I think you can. I just don't think can you? Do you know the answer to that, Warwick? I don't
I
think
would
you
believe.
can you?
We'd have to have a look. I think your performance, well, your size of that index would be quite large, depending on how much you're putting in. It's going to be variable.
Yeah. Yeah, that's one I would have to. I've never had a reason to, so that's the only reason I don't know the answer to that is because I've never had a reason to want to do that. But that's an interesting question. I will actually look that up and.
Okay, so I've just had no, we can't create it on a max data type, but you can include it in the as an include.
Oh, as
column.
an include. There you go. Okay, there you go.
Thank you, Jeff.
Thank you. Thank you. I didn't think you could, so.
Okay. Is there a penalty in defining your own data type, like create type SSN as a char9?
When you say penalty, that has different connotations to different people. So it's still going to have to, if you're going to port it to some other system, you're going to, so I guess the short answer is yes, but not really. Does that sound like I'm on the fence enough on that one or not?
That's okay.
Yeah, so I would have to do, so as far as like performance testing, and I would have to actually bring up some use cases and do that so I could give you definitive numbers. I haven't seen any situations where using a custom data type like that has caused performance issues, but maybe that's because I had a smaller sample of data that I was using. That's just me though.
Okay.
You got any more?
Quick one. We're here. So I converted a calendar table, day, weekday, month, etc., from int to tiny int.
Okay.
Select star from calendar, and it changed from 31 meg memory grant to a 5 meg. Oh, I just had a question come in and it's moved. The 5 meg calendar is used a lot. Okay, probably need a little bit more information on that one to give us an answer. But basically, the way I'm understanding it, so it was changed from an int to a tiny int, and it goes with what you were showing before with the sizes, changed from 31 meg to 5 meg.
Okay. Okay. And that would make sense because you're storing a lot less data. You're storing what, 1 byte versus 4 bytes? I have to go back because I don't remember. So tiny int versus an int, yeah, 1 byte versus 4 bytes. So yeah, that makes perfect sense.
Okay.
All right. Are we good to talk about dates now?
Let's go.
Okay. All right. So dates, temporal data types. So you've got the date time 2, date time, small date time, and date. So if you don't need to store any time piece with that, just use a date. If all you need is an actual date, just use the date data type. If you don't need super accurate, but you need a time element to that date, use a small date time. It's accurate to the minute. Date time, it's accurate to the millisecond. Oh, whoops, I hit the wrong button. It's accurate to the millisecond, but just know that it's also rounded to only these 3 numbers. I found that one out the hard way. I was doing some testing and we wanted to modify some dates. So I was just adding, 1 millisecond and my stuff wasn't changing. And it, took me about an hour before I finally hit the books online and discovered this one. So learn from my mistakes. And then again, if you need to be super accurate, you can get down to 100 nanoseconds with a date time too. But again, you need to understand the languages that you're using. Not all of them recognize all of the temporal data types. Some of them don't recognize a small date time. Some of them don't recognize a date time too. So you're going to have to do your research to find out what is going to be accessing this stuff to make sure that you know. And with that, let's get down into our demo. So now we're talking about dates. So I got to do a little bit of cleanup here. All right. Come over here. And I have, again, taken a table from the Wide World Importers. It's the order table. We've got an order date, and they're just storing it as a date data type. I created copies where I'm storing the same date as a date, a small date time, a date time, and a date time too. They've all got the exact same data in them. So let's come back and let's take a look at our small table, just like we did with our strings and our numbers. So we've got almost 70,000 records, and they're pretty close in size. A date versus a date time too, you're only looking at about 300K difference. Not that big of a deal. But again, we always want to make things go faster, so we add indexes to those. And let's see how that affects our storage. Let me zoom in here. And again, it's a little bit more than doubled in size. So now, instead of a 300K difference, we're looking at a 600K difference for the exact same records. Still not that big of a deal. But again, what happens when you've got that big table of 10 million records in there? So instead of going, a 300K difference, now we're looking at almost a 50 meg difference. So not a huge difference. And again, we always want to create those indexes. So let's do that. And I scrolled down too far, so you guys already know what the answer is going to be. So it's actually going to go from a 50 meg difference to a 100 meg difference once we've added that index on there. This one takes a little bit while to, again, I got that faster machine. Everything is so much faster now. Wow. I'm going to have to adjust my, whoa, that was really far. Didn't mean to do that. All right, yep, so now we can see that's about 100 meg difference once we've got that index in there. 100 meg in the grand scheme of things, when you're talking 10 million records, not that big of a deal. But again, don't tell your SAN administrator I said that. I don't want him to come looking for me and running me over in my parking lot. All right, so let's get back to our slide deck. Before we keep going, do we have any questions on dates?
We have, yes, so I have a table with a date time column, but okay. I want to search between from and to dates, which are date type only. How can I avoid a scan?
So you have a table with a date time column in it, and you need to...
But I'm only wanting to, if I'm reading this correctly, it's moved. Let me, but I want to search between and from using the I'm assuming the date. Yeah, so only looking at the date, not the time part of the date. How can I avoid a table scan?
Well, when you say you don't want to use the time part, does that mean that it just needs to be, so if you're talking, anytime on January 1st, through, anytime to January 31st, and you don't care what time it was? Is that the kind of thing? Or is it, because that's my assumption.
That's my assumption as well.
Okay, so what I have done in the past, when I'm just given an actual date that I have to do, and I have to look at a date time column, I will try to convert it to a date time. So if it's a parameter that's being passed as a date, I will typically add the time element to it and then use those variables to compare. Then it will use the indexes that are there. Because again, if you compare a date time to a date, they're not the same. Somebody's got to use the implicit data type. Somebody has to give. One of them has to be converted to the other, and it's not going to use that index. It's going to use a scan. So that's how I've always done it in the past, is I have, appended times to it. So my start time, I always add the zeros onto the front of it. And then on the end time, I always add the, 23, 59, 59.00, whatever, on there. And I've used those variables to do that comparison. If that is not an option, then, and you do actually have to compare a date to a date time, it's not sargeable, which is what we're going to talk about in our performance, and it's not going to use those indexes. There's not really any way around it that I know of. Do you know of any way around it, Warwick?
No.
Okay. So that's just what I've done in my experience. If I have the ability to convert one to the other, then I do it, and then I do the compare, and then we'll use the indexes.
Okay, so if we've got a date time 2, and that it's smaller than a date time, why would we want to use a date time?
If the language that is being used to pass may not support a date time too.
Mm-hmm.
That's the most common scenario that I come across, is that the language that I have to use doesn't support a date time too, so I have to use a date time.
So other than the supportability from that language, not really anything that we've come across before.
No.
Okay. Any suggestions when we should use a date time offset?
Oh, I avoid offsets like the plague. So if there's any way I can avoid it, I do, because it makes my brain hurt, quite honestly. And that's my best answer.
Okay.
All right, are we good to keep going?
We are good to keep going.
All right. So not all dates are created equal. The storage, when you compare them to the numbers and to the string, the storage isn't as big of an impact. It's more of an accuracy. It's, again, know your data domain. What kind of accuracy do you need with that date? So the big winner is, when you're talking about 10 million rows, dun, 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 the varchar versus the char. So, 2.5 gig if it's just data. If you add an index on it, you're looking at 5 gig. And don't take these as the gospel. These are my sample data, which are kind of average size, datas that's being stored. So it gives you a real good idea. So, like I said, the date versus date time too, not a huge thing. Numbers, a little bit more impactful, but definitely char and varchar is a big difference. Okay, and with that, we're going to talk about performance. How are we doing on time?
Yeah, we've got a little bit of time to go. That's okay.
Okay. So performance, we're going to talk about how it affects your execution plans and your I/O. So execution plans. We want our execution plans to be sargeable. So Gail Shaw, who is SQL in the Wind on Twitter, she's out of South Africa, has some great white papers where she's talking about sargeability. And essentially, sargeability means that your predicate will be executed using an index seek, not a scan. So, and that's what we want. We want our stuff to go faster, as fast as we can. So, you know, if you are doing any kind of functions like a date add on a column, and you're comparing it to a variable, that's not sargeable because you've got that function on there. It has to do what I call, has to do engine math to figure out how to compare those things together. But if you're comparing a column to a variable and those things are the exact same data type, then it's sargeable. There are no external operators on either of those expressions, and they can just, the engine says, yes, I've got a match. I don't have to do any conversions. I don't have to do any engine math. Life is good. Let's use that index seek. So that's our goal, is to not have to do an additional step in that predicate. So with that, there is a conversion precedence. So, like in mathematics, you have the order of operations. You have to do multiplication and division before you can do addition and subtraction. Well, the same kind of concept exists when you do conversion. You have to be able to, because the SQL Server engine isn't smart enough to compare two different data types. They have to be the same data type. So it's the one with the highest precedence that takes order. And how I like to think about this, and how I remember this, is that a tiny int, which is just a 0 to a 255, can always be a small int, but a small int, which could be a 500, that cannot be a tiny int because it only goes to 255. So that's how I remember. I've got the hiccups, I'm sorry. That's how I remember the order of precedence when I look at this list. So with that, let's get started on our demo for execution plans. All right, so I have, so like I said, I got a fast new machine here. So I have to, I'm gonna put a load on my server on a CPU. So we're just gonna start this, and it's just gonna keep churning away in the background. And we're gonna come over here, and we're gonna set our statistics time on so we can see how long it's taking the CPU. We're just going to clear our buffer cache, and then we are going to compare an integer to a variable, which is an integer. So we're comparing an integer to an integer, and we're going to see what happens here. And when we come over here, we look at that, that's pretty fast. That's pretty fast. All right, well, what happens when we come over here? Did I forget to, I forgot to turn on my actual execution plan. So let me do that again. All right. When I come look at my actual execution plan, look at that. I've got an index seek. And remember how I said we were talking about the predicate? Well, here's our predicate right down here. And it's comparing an int to an int. So it's all good, it's all happy. But what happens when we come over here and we compare an int to a varchar? So it's the same data, I'm just storing that data as a varchar instead of an int, and then I'm comparing it to a variable, which is an int, and that is a varchar. So let's see what happens here. So let's execute that. And it's still pretty quick. Let's come look at our execution pan, but look at that. Now we have an index scan. And when we look down here, look what's happened. Our predicate is now at the top, and we have this convert implicit, which wasn't there in the last one. See, it has to convert it to a string in order, because it's comparing a string to a number. And an integer can always be a string, but a string can't always be an integer. So the string takes precedence there. And that's what it's doing. It has to convert it. So that cost us extra CPU cycles to do that. That's where we're going to take that performance hit. Now, it wasn't a huge performance hit because this isn't a really big data set that I'm looking at. But what happens if you have to run that query hundreds or even thousands of times in an hour or even in a minute? Those CPU cycles add up really fast. So even though it may be something super small, if it's something that is executed, millions of times, that CPU time is really going to add up. All right. So now and those were small tables. So what happens if we have a big table with 10 million records in it? So, I hit the wrong one. So it's taken a little bit longer, not a whole lot longer, but a little bit longer. And again, it's using that index seek. And we can come down here, and our seek predicate is down here at the bottom. So we're all set there. It's sargeable. We don't have an implicit data type conversion. And now what happens when we compare an int to a varchar on that big 10 million record table? Again, it takes it a little bit longer. And when we look at the execution plan, look at that. It is doing an index scan, and our predicate is back up here again, and we've got a convert implicit again. It has to do that. And again, our CPU cost has gone up. If we only have to execute this once, it's not that big of a deal. But again, if this is something that is going to be executed hundreds, thousands, even millions of times, those CPU cycles are going to add up really, really quickly. All right, do I have questions on how it affects your execution plan and your CPU cycles?
No, we don't have any questions on that.
Okay,
so we can.
I'm gonna stop this workload. All right, let's go back to our slide deck. Pick up where we left off. So, okay, so we've talked about how it affects your CPU, and we've talked about how it affects your storage, but another way it affects your storage is this concept that I call fat tables. So, we were just looking at one column in one table when we were using, that char 255. Well, what happens if I take a table and I make everything a char 255? That is a character data type. So here's my original table over here on the left side that's using the correct data types for the columns. And then I've created a copy of that table, but I've created it using char 255s where I could. So let's see what happens. So when you add up all of the lengths of the data types on the left, it's about 2K, but when you add up the ones on the right, it's a little bit more than 6K. So let's see what happens when we have one of those fat table scenarios. So again, my machine is super duper fast, so I have to kind of slow it down. All right, and let me do a little bit of cleanup here. All right. So I've got two tables. I've got my fat table and my original table. They have the exact same data pieces in it. There's only 10 records in them. As you can see, we're looking at this. It's all the exact same data. I want to see how many pages it's taking to store this data. So SQL Server stores data in 8K pages. So if we look at the DBCC end, which is one of the functions that will give you the number of data pages that's being stored. So let's take a look and see. When we look at this, anything with a page type of 1 is a data page. So right now it's only taking 1 data page to store the original table. But how many pages is it taking to store that fat table that was, you know, more than 6K per record? So when we look at this one, look at that. We've got 10 records, 1 for each record in the table. It's using 1 page. That's a lot of wasted space. So when we come back over here, let's see how much space they're actually using. So let's zoom in here. So they both have only got 10 rows. Our original table is 24K and our fat table is 80K. Well, that lines up with what we just saw when we looked at the number of data pages. So let's insert a small record into each table, and we're going to use the exact same data. And when I say small, we're just adding, you know, small pieces of data here. It's not big data in length. So let's just add the exact same data to both of those tables. And I'll show you. I really did. We now have 11 records. There's that record that we added to each one of those tables. And now let's go back and see how many pages it's taking in that original table. So before it was only using 1 data page to store those 10 records. We've added, now there's 11 records, 11 rows, and it's still only using 1 data page to store all those records. But if we come over here and we look at the fat table, look at that. We have an additional, now it takes 11. So again, 1 page per record. That is wasted space. That's 2K that's being wasted per page. That's a lot of wasted space. Don't tell your SAN administrator if you find that. So let's see if that lines up with our storage. And sure enough, it does. We were at 24 before on the original table and 80 on the fat table. Yep, it added that extra data page in there, sure enough. So when we come over here, now let's look at a table that has 100,000 records in it. So when we look at the original table, we get 6,671 records, and one of those is a header. All the others are data pages. I could scroll through that entire list, but I don't want to bore you. But what happens when we look at the fat table? Let this finish executing. I think it's going to be a little bit more. Look at that. Look at that. 110,000 pages to store the exact same data. So 6,000 versus 110,000, that's a lot of wasted space. Let's see exactly how much. So 110,000 records, 53 meg versus 880 meg. That's almost a gig difference. That's almost, look at all that wasted space. So you really want to make sure that, if you've got, and I've been guilty of this myself. I just want to load this data. I have no idea what size the data that's coming is, but I know that if I make them all, 500 characters long, everything will go in. So that's what I'm going to do. And because we always say we'll go back and fix it later, and we always do, never, that lives on forever, and that's always wasted space. So just know if it is a one-off, truly go ahead, do it, be my guest, waste that space once, and then get rid of it. But if it's something that is going to persist, you really need to take a look at the design of your table and make sure that, those are the sizes that you need. All right, so if you want to see how this affects your I/O, because if we're using more data pages, that means we're using more space on the disk. So we want to see how that affects our I/O performance. So I've got a little thing that's going to go hit my hard drive. So that's going to be spinning to make it look like it's a really fast or really busy server. And then I'm also going to disable my read aheads for sequential reads, which means I'm forcing it to fetch that data from the disk. I do not recommend you turn this trace flag on in production. That could be a resume generating event if you do. So let's just turn that trace flag on. Now we're going to clean everything up to make sure there's nothing left in memory. And now we're going to come over here and we're going to grab from the original table and see how that affects our I/O. So we come over here. Oh, I guess it would help. I did run the set statistics I/O on, didn't I? Did I forget that piece? Probably. Okay, so let's run this again. Come back over here. All right, so look at that. There's that 6,670 logical reads. So that's the number of pages, and that translated to 833 physical reads from disk. Now I've got a solid state drive in here, so it was pretty fast. It didn't actually take very long to do that. But what happens if I'm going to go look to see at that big fat table that's got those 110,000 records in it? See, it's still going. It's definitely a lot slower than looking at the original table. It's still going. This is all I/O. This is all I/O. It has to go out there and it has to get all those pages. So those 110,000 pages, that translated to over 13,000 physical reads. Can you imagine if I didn't have an SSD, how long that would have taken? Yeah, that's a big, big impact right there. So fat tables can definitely affect your performance, because you're going to be, if you're still running on spin and rust, that is a huge performance hit. All right, I am going to go stop this right here so that it doesn't kill everything else on my machine. All right. Oh, let's get back to our slide deck. So, impact on performance. We've seen how it can affect our CPU time by the implicit data type conversion. So if you're comparing two different data types together, that's going to be a performance hit on your CPU side. It's going to affect your execution plans. You're going to get table scans and index scans instead of seeks. And then more pages means more disk I/O, which means it's going to be a lot slower. So with that, that's kind of the end of it. Are there any questions out there for me, Warwick?
Okay, so can you give us a rundown or a difference between using account big versus account, and what type of impact they may or may not have for us?
So a count big and a count.
Yes.
So the impact performance between those two, the difference between those two.
Yes.
I've never actually looked at that difference. I'm sure there probably is one, but what it is, I honestly don't know. I'm adding that to my list of things that I have to research. All right.
Right. Is there an easy way for me to know which of my data is in row data versus row overflow data?
So if you go, oh, I already closed that one. So the DBCC end, it tells you when it was in-row data. So that page type tells you. So if you use that against your table, that will tell you. I can't remember what the type was because the 10 is a header, 1 is a data page, and I cannot remember what the number is for an overflow page, but that's how you would find that. The DBCC IND.
Okay. Just making sure. Oh, we've got can you tell what the configuration of your new machine is, please?
So I have 64 gig of RAM, and I have a solid state drive that is 2 terabytes in size. I don't have the specs on the actual solid state drive in front of me, but it's one of the brand newer ones. It's a SanDisk that just came out.
Okay, so yeah, so you're not sure on what brand. Sorry, Jeff. Okay, everybody, if we haven't got any further questions for Angela today, I would like to thank Angela for her time presenting to the DBA Fundamentals Down Under. There we go. Feel free to reach out to Angela via her Twitter handle, read her blog posts, connect via LinkedIn. And if you've got any questions from today, there's the email address that you can contact Angela. And with that, I look forward to hosting you all same time in a month's time. Thank you, everybody.
Great, thank you.